I'd like to invite Don MacAskill from SmugMug to come up on stage and talk to us about the SmugMug tale. Give a round of applause to Don MacAskill.
So I'm the founder, CEO, and chief geek at SmugMug. As you can see, I am a superhero, and I work with a lot of other superheroes. We are a premium photo and video sharing company. We were started in 2002 with no investors, and we still have no investors today, which we're pretty thrilled with. We are a private company, so we no longer talk about our revenue numbers now that they're large enough for people to actually pay attention to us. But the last numbers we talked about in 2007 were 10 million a year in revenues. We've been profitable for years. We have no debt, and we're a top 400 website. And our scale has been doubling every year. So it's been aggressive growth, but not YouTube or Facebook growth. So it's been a lot of fun to try to keep up with it. And it is growing faster than hardware would have been able to keep up with if we could still rely on gigahertz increases, which of course we all know we can't. We are a premium photo sharing site. By that I mean there aren't any free accounts. Everybody pays for service with SmugMug, and as a result they expect bigger and better things. So every account does get unlimited storage and unlimited bandwidth. They get to upload huge photos right off of their camera or scanner or wherever else they got it, up to 48 megapixels in size. And we have more than 500 million of them. So you can imagine how difficult it is for us to serve them all and store them all and all that sort of stuff. We also support video all the way up to 1080p, so close to Blu-ray quality, which has been a big win for us recently, and it's a whole lot of fun. And our customers expect lots of photos and videos on each page. So if any of you have used our service before, you go to a page and we'll fill up a 30-inch display, or we had one customer have 4 30-inch displays that they wanted to fill up simultaneously, and our interface does that. And they want it to be super fast. So filling up 4 30-inch displays with tons of photos really fast is an interesting problem for us to stay on top of. So let's talk about how we do that. We are a lamp shop, like tons of people in the audience, I'm sure. We're x86, mostly 64-bit, mostly AMD, although we're really, really excited about Nehalem. We have, we're relatively small compared to some of the other people that have been up on this stage, but big enough to keep things interesting. We have 4 data centers, 2 in Silicon Valley, actually 3 in Silicon Valley now, I think, so I guess that's up to 5. 1 in Virginia and 1 in Seattle. So we are spread out a little bit, but nowhere outside the US yet. And one thing that we're fairly proud of is that we only have 2 operations guys. So an awful lot of the work we do is geared around not just performance and high availability, but minimizing the amount of man hours required to install and maintain all of this stuff. So one of the things we do is all of the customer-facing web boxes don't have any hard disks in them or anything to configure. They are completely diskless. They just boot and figure out what their role is by booting and asking for their role, which turns out to be a big win in terms of keeping our headcount down. And along those same lines, we consume a lot of cloud services. So I'll talk in a minute about S3 and EC2. But we are really thrilled with the move in that direction. So for storage, we store our binary data, the photos and videos, both the ones that you upload and all of the other sizes. So if you upload 1080p video to us, we generate a bunch of different sizes, including one that plays great on your iPhone or iPod. All that stuff is stored up at Amazon S3, and we now measure our storage up there in petabytes rather than terabytes, which is pretty cool. And we do use Akamai, I'll talk about that in just a minute, as a front to caching all of that stuff closer to you, the end user. For our structured data databases, we use MySQL, and almost all of it is InnoDB. Our instances are fairly large. Most of them are 8-core these days, dual quad-core. using the Shanghai CPUs from AMD. And they tend to have 64 gigs of RAM in each node, and they're fairly big storage-wise. We have tables that are hundreds of gigabytes and databases that are multiple terabytes. And we use, like many of you, I'm sure, memcached to cache that data so that we keep a lot of the load off the database tier. For compute, we do the photo and video processing and encoding in Amazon EC2, so none of that stuff occurs in our data center. The really nice bits about that are that we can scale up and down. The down part is super expensive, super important too, because all this compute is expensive. So, at 4 a.m. or something when we don't have an awful lot of videos or photos being uploaded, we can scale down to just a handful of instances. And on Sunday night, when we have lots, we can scale up to tons and tons of cores, many hundreds of cores, if not thousands. We wrote a piece of software that we call Skynet that handles that scaling. It's all totally autonomous. The reason it's called Skynet is it did try to take over the world and launch thousands of instances once when I had a bug. For our customer-facing hardware, again, the web boxes are all stateless, diskless. So they pixie boot and they say, hey, I'm a machine. Do you have some role for me to be? And we say, yeah, go be a web server or go be an upload server or whatever it is. If we need to change its role, no big deal. We just reboot it, and it gets a new role when it comes back up. Pretty handy. With MySQL, we're both scaled up and out. We think that's fairly important. There's no reason why we shouldn't take advantage of all these cheap multi-core CPUs and cheap RAM. And I think you can get 64 gigs of RAM for like $3,000 or something. So it's ridiculously cheap. And maybe my math is off a little bit there, but. And same thing for memcached. It's fairly cheap to build big memcached boxes, so we have a lot of it. We have somewhere around 1 terabyte of data stored in memcached, and we'll talk in a later slide here about how we use that. So one of our secret weapons is Akamai. I haven't talked about this publicly before, but we rolled it out last year, and it's been a huge, huge win for us. So if you're a website considering speeding things up, Akamai is a potential to look at. So the big issue with Akamai, of course, is that they're a CDN, and just like most CDNs, they try to help move data closer to your customer. So that's really great, but the reason we chose to go with them and the reason I'm so excited about them and talking about them right now is that they go beyond CDN. So we have them, so let's say you're in Australia and you make a request for a page of photos with SmugMug, and that request is coming back over Akamai's network from Silicon Valley to Australia. Well, their servers along the way inspect the HTML and the JavaScript responses and look for stuff that they can ask for and get from our data center and send to Australia before your browser even sees the HTML or the JavaScript. So by the time the page loads and it starts to ask for all those photos, they're already in Australia. They're not 200 milliseconds away in Silicon Valley. That's pretty huge for us, as you can imagine. So we can really minimize the milliseconds required to draw our page loads, and the network path across the world is optimally served through Akamai instead of through the transit providers we have, and we even use them to distribute DNS. So when you do a lookup, the lookup occurs in Australia or South Africa or wherever you happen to be. It is expensive. We're lucky that we're a premium service. We are not ad supported or anything, so we can afford to, and our customers demand that we spend some money on things like this that dramatically improve performance. One of our other secret weapons, or not so secret weapons, is memcached. I'm sure lots of you are familiar with it, so I won't spend too much time on it here. But it is screaming fast. We get requests back in like 70 microseconds or something. So it's super, super fast. We have a lot of it, like 1 terabyte of data stored. And most importantly, we have a really high hit rate. So our cache hit rate on memcached is above 96% pretty much any time of the day, which is really quite nice. It tends to contain mostly MySQL row data. So we just grab a row straight out of MySQL, or more likely a lot of rows, and then shove them into memcached and are really good about expiring them later if they get updated or whatever. But that way we can avoid selects on our database tier to actually get row data out. We make sure that most of our selects are just for index lookups. We do serve other data in memcached, like search results and things like that, but MySQL so far has been by far the biggest win. We've been using memcached for, I don't know, 4 years or something, maybe 5, whenever it first came out, basically. And of course, we do fall back to MySQL if we try to do a read from memcached and get a cache miss. MySQL, the reason I'm here is that it is absolutely the most important technology at SmugMug. We couldn't have built our business without it. I don't know where we would be if it wasn't so great back when we started and hasn't continued to be great. And one of the features we love most about it is replication. We depend on it a great deal for not only performance, but reliability and high availability. Mark was up here the other day giving his keynote. He said he had never lost data because of MySQL. We're in the same boat. It's been years now. We have a lot of data. None of it has been lost because of MySQL. I don't think we've had any data loss at all, but the times where it's been dicey, it's been R bugs or something rather than MySQL. So that's been really, really great. It's one of the big reasons we use MySQL. In fact, you'll see in some later slides there are cases where we aren't really doing much relational with the database, but we use it because it's so reliable, and the data, we know if we stick data in there, it will be consistent, and we can get it back out, and we don't have to worry about it. So that's a big, big deal. So our MySQL implementation is sort of interesting in a few ways. We're, like many web scale companies, we don't do joins. And plenty of the other features that have come along with some of the 4x releases and especially 5x releases, like stored procedures, prepared statements, views, foreign key constraints, all that sort of stuff, we don't use any of it. So we'll talk about it a little later, but I'm excited for things like Drizzle that sort of go back to lean and mean MySQL, just because that's the way we use it now. We are vertically partitioned, not horizontally, so there have been quite a few great talks about sharding and everything. We've been close to pulling the trigger on sharding a few times at SmugMug, and luckily we've been able to avoid it because either some great MySQL release comes out that solves our scaling problem, or maybe an innovative piece of hardware, or usually a combination of both. So one of the themes later in this presentation is that hardware plus software is really where the magic happens. Many of you, I'm sure, have iPhones or have used iPods or things like that. I think it's a great little example of hardware and software combined is better than separate. And in this case, I think you need hardware innovation and software innovation, both of which Sun has been delivering. InnoDB deserves its own slide. Again, it's mostly what we use, and it is absolutely the most important technology here. I just want to give a shout out to Hiki and Oracle for building it and supporting it and improving it all these years. We couldn't have built our business without it. And then to Percona and Google, who in the last year have, as you've heard from other presentations, have really sort of been driving forward with concurrency and I/O related patches, which MySQL and Oracle have been accepting recently and releasing great new versions. So those guys have been very helpful. We are running the latest InnoDB 1.03 plugin with some patches from Google and Oracle. Percona calls it ExtraDB. It's really InnoDB with some stuff that will likely be in InnoDB proper in the near future, I hope, in production. And we've seen big performance gains with the recent releases. So if you are concurrency bound or having I/O issues, definitely take a look at the latest releases from like 5.4 and 1.03 and all that sort of stuff. I want to call out Percona too. They have turned out to be an awesome vendor for us. We We're a MySQL enterprise customer and have been for years, and we love the support that Sun and MySQL provide. But when it comes to sort of crazy bleeding edge stuff that we do, we often get blank stares. So we turned to Percona later this year when we ran into some nasty problem where we were seeing up to 3-second timeouts connecting to MySQL. And I beat my head against it for a couple of hours, looked at every setting I knew how to look at, tuned the Linux kernel, looked at my Ethernet switches, everything I could think of, and it turned out to be a rare InnoDB setting or MySQL server setting I had never heard of called back_log. Turns out it tunes the TCP backlog pressure, and Percona was able to get me sorted out, and it was really, really awesome. So, and they have been one of the catalysts behind the great 1.03 InnoDB release and the improvements with 5.4. So they're really doing some great work. If you need some bleeding edge stuff like we do, they're one possible shop to talk to. So as far as details of our implementation, write latency is the thing we care about most when scaling our platform out. Okay, so maybe I'm wrong, data integrity, but we already covered that I can rely on the data integrity for MySQL, so we focus on write latency an awful lot. And the reason is that scaling reads is relatively easy. Through replication and memcached, we can scale reads much, much easier than we can scale writes. Our replication needs to stay current because of the way we wrote the site, so we try to keep our slaves that are actually being read from and in production to less than 1 second of lag, and we paper over that 1 second using memcached. Up until recently, there have been MySQL concurrency problems that have been well publicized and talked about. Yasufumi talked about them a year or two ago at this conference, and both MySQL and Oracle have made huge strides there, so we're really excited to see that. Of course, we want lots of parallel I/O now because we have lots of cores, and we're dealing with fairly large storage, terabytes worth of data. And finally, we use big RAM. We have 64 gig in most of our MySQL boxes, and we can't wait to go to 128 and beyond. RAM is fast, and we want lots of it. Like I mentioned earlier, our stuff is not very relational. We act an awful lot like an indexed key value store. So most of our selects are selecting the primary key from our table using some index where clause. And then we go and get all the primary key row data out of memcached. Only on a cache miss do we go back to the database and do a select star from the table. Often it's a select star across quite a few primary keys, so we can load a block of data into memcached. But again, we have a 96% or above hit rate, so an awful lot of the selects just come right out of memcached super fast. And again, the updates and deletes are also tend to be on a single key. That way we can easily invalidate our memcached, and we can keep track at a very fine-grained level exactly how far behind our slave replicas are. Our data is very denormalized. We don't do joins or complex selects. They're all really, really simple. They're all on indexes, which is one of the reasons we like a lot of RAM. We want to keep all those indexes hot and in RAM as much as we can. So when running benchmarks against new hardware or new MySQL or InnoDB releases, the OLTP benchmark is a useful metric for us, but it's not perfect. So we've been sort of getting itchy to maybe add a test to it or something to improve it. If anybody else wants to collaborate on that, we think maybe we can come up with a better web workload, or even better, more configurable test, so you can map it to your workload better. I want to talk about some of the MySQL issues we've faced and how we've solved them or are working on solving them. Before I do so, though, I just want to again reiterate that we absolutely love MySQL, so I don't want to come off as complaining here. We wouldn't be in business without it. But nonetheless, we're actively trying to improve our use of it and of course, share with the community what we've learned. We're a Linux shop. and Linux's state of file systems is sort of archaic, in our opinion. ext3 eats itself sometimes and just isn't that reliable. Our MySQL instances are very storage intensive. They are large, hundreds of gigs per table sometimes. We do an awful lot of IOPS, etc. So having a file system that isn't very reliable is a big problem for us. ext4 is out or on the horizon, but it's already old and busted as far as we're concerned. We just want to be done with fsucks. We'd love to have really great volume management. We've used LVM for years, but it's sort of lacking in a few areas. And ext3 even has a problem where it has to serialize writes to a given file, which is a big pain in the butt. So the obvious solution is ZFS. It's transactional. It's copy on write, has end-to-end data integrity, which is one of our biggest issues. We want to be able to know that data is consistent on disk and have it cover up driver errors or system failures, drive failures, bit rot on disk. We're dealing with terabytes of data, so bit rot is getting to be a bigger and bigger likelihood. All that sort of stuff is covered by ZFS. There's on-the-fly cache corruption or corruption detection and repair. So when you do a read from like a RAID array, if you get some bad data, it can go and find the other bits and give you the good bits and overwrite the bad bits with new good bits. Pretty awesome. The volume management is light years beyond LVM. The snapshotting and cloning stuff I'll talk about soon is really great for MySQL. And of course, it's open source software, which is basically a requirement at SmugMug. But the real issue is we run Linux. ZFS doesn't run on Linux, so that really sucks for us. One of the other big issues for us is replication. So if your slave crashes or you kill9 it or storage disappears or whatever and you bring it back up, replication is in an unknown state because the writes to the replication slave log and InnoDB's commits are not atomic. So you sort of cross your fingers and hope that your metadata related to where you were in replication is correct, but you never really know unless you actually analyze it. In our case, we ran into some data that was 2 months out of date, and I'll talk about that in a later slide. That was really eye-opening for us. Plus, we often want to bring slaves up quickly. When they're multiple terabytes, that's like 4 or 6 hours across gigabit Ethernet to copy, and then your slave is behind by 4 or 6 hours, so it takes a while to catch up. So that's sort of a pain. We've been doing backups with LVM for years, which has been really, really great, especially on the large data sets we have, except that you have to do something on the slave, like stop replication for a few seconds, or flush tables with a read lock, or shut the slave down, or something to take a consistent snapshot, again, because the metadata might not be in sync. When a master fails at SmugMug, we promote a slave to master and then reparent all the other slaves, and that's been a little kludgy. Keeping up with the master has always been an issue for us, mostly because the replication thread is single-threaded. So the transactional replication patches coming out of Google are turning out to be awesome for us. The slave is always in a known state. You can kill -9 the slave and bring it back up, and either it will be in a known good state, you can verify that replication is in a good state, or if not, you have the data in the MySQL log to issue a change master statement, and you're back in business. So you can take snapshots out from under the slave without doing any flush locks or flush tables with a read lock, shutdown, or slave stop, any of that sort of stuff. It's safe to uncork InnoDB, so to speak, and tell it not to sync to disk every single write. It is for InnoDB only, so if you use other storage engines, that's going to be a problem, but Google is working on it. You can Google for global transaction IDs, and Mark Callaghan has blogged about it. It looks pretty great. We are using it in pre-production only right now, but we hope to be in production maybe next week or sometime. I'm busy killing slaves like crazy and making sure the data is intact. Once we're satisfied, we'll move on. So one of the solutions to quite a few of the problems we just talked about has turned out to be a hardware solution. And it's called Open Storage. The internal code name for the particular open storage box we're using is Toro, and the product is the 7410. It's a storage appliance. It's a NAS box sitting on your network that happens to have a bunch of Opteron cores in it and RAM. But the important bits, to me anyway, are that it has SSD built in, fronting disk. So they have write-optimized SSDs, they call them writezillas, that have RAM in the SSD with a supercap to back it up and drain it on a power failure, so that writes occur super fast, near RAM speed, and I have a slide on that in just a minute. And then there's a separate read-optimized SSD layer that they call readzilla that's quite large. It's I don't know why my slide says 100 megabytes. It's 100 gigabytes per device, and you can stack a bunch of them together, so you could do like 600 gigabytes or something. And then they're just commodity, cheap hard disks behind them. And it turns out that we get SSD performance on these boxes, but we get an awful lot of storage. When we do RAID 10, we get like 9 terabytes usable. So we get essentially what behaves like 9 terabytes of SSD for our workload anyway. That's pretty huge. And there are some other reasons why this is great. It basically solves my ZFS on Linux problem. So all of our Linux boxes can just mount these ZFS mounts and use them over NFS. Pretty awesome. We're excited to see SSD be here, and better yet, in my data center. Since it's backed by disk, we get SSD performance, but closer to hard disk pricing, which is really, really nice. The box exposes NFS, iSCSI, CIFS, HTTP, FTP, everything. We're using NFS. And it gives you all kinds of flexibility, which is probably obvious, but I'll talk about some of those things. The Fishworks interface, I forget what Fishworks stands for, but it's their interface to manage and configure these things, is really amazing, especially their analytics stuff. And I'll get to that in a minute, too. It's priced fairly well, as long as you don't trust Sun.com's sticker price. Nobody pays list price. Nobody pays anything even close to list price. So if this sounds interesting, ask somebody at Sun to give you a real price. If you're lucky enough to be a startup like we are, go through Startup Essentials. It's a crazy, crazy price. I had it on the slide, but I didn't know if I signed something that prevented me from saying it, but it's really, really good. And then finally, it turns out that we can stack an awful lot of MySQL boxes on each of these. So it's not a one-to-one mapping. For us now, it's more like a 10-to-1 mapping. So you have to divide the price by 10 so far, and we think maybe even more, to come up with a per-node price. And it gets ridiculously cheap once you start doing that. So we now have 5 of these things. They are in various states of pre-production and production, but they're turning out to be pretty great. They are scary fast. So this is I'm sorry, it's a little blurry and stuff, but this is a blow-up from the analytics software running on the box, showing us doing 10K sustained IOPS to the box. You can see 4,500 of those are under 43 microseconds. This is the entire NFS operation, not just writing to disk, but processing the packet and getting the response back and everything. 8,000 of them are under 166 microseconds. So it's really, really, really fast. The default configuration, I think, has 2 of the SSDs in it, so you can do a theoretical max of probably 20,000 IOPS. If you need more, you can just add more SSDs. And it is quite scalable on our Linux boxes. So we're able to, on an 8-core box, push 15,000 4K synced write IOPS using 16 threads. And the latency doesn't get too terrible even when you're doing pretty high concurrency. So at 3,000 IOPS, we see about 250 microseconds. So that includes all the network latency plus the stuff from the previous slide. And at 10,000 IOPS, it's still under a millisecond. It's 700 microseconds or so. So that's really great. We are stacking MySQL instances on these like crazy. So we have 8-core MySQL boxes, In this case, I think we have 8 of them on a single Toro. And so they're all mounting, NFS mounting their various mounts and just shoving reads and writes down the pipe. And our appliances aren't even breaking a sweat. We've tossed 5 very different workloads on it, ranging from really write intensive to almost no writes and lots of reads, and it's performed well with all of them. Of those 8 slaves, that is, 5 of them do differ in workload performance, so that's what that slide means. And we are using compression on many of those mounts too in the device, which we get quote unquote for free because it's not using precious client CPU on our MySQL boxes. Instead, it's using CPU, which otherwise would be idle on our storage appliance. And we're seeing about a 1.5 compression ratio across terabytes of InnoDB. Backups are a breeze. Again, with transactional replication, I can just take snapshots like crazy out from under my slaves, and this box lets us just set up scheduled snapshots. So we have many of our things just being snapshotted once an hour like clockwork. No need to do anything on your MySQL box, and then you can copy the snapshots off to wherever you need them, offsite, across the country, wherever. You can roll back at any time to a snapshot, so if you've got a bad SQL statement, which I've been terrified about for 7 years, but it hasn't happened, thank goodness, you could just roll back and step through your replication log, skip that statement, and then move on. Bringing up a new slave is no longer a multi-hour process, it's a multi-second process. You just click snapshot, click clone, and you're done. Just mount the NFS, the newly created NFS mount, and start MySQL. It'll do InnoDB recovery, and it'll be in a consistent state. Pretty awesome. It basically lets us use DTrace, another great Sun tool that isn't available on Linux, on our storage layer, which is really great. That's how I got the microsecond readings on the NFS write transactions. That was basically a graphical, a really great graphical interface to DTrace. So definitely take a look at that if you manage to play with any of these. It is totally, totally awesome to actually know what your storage is doing before you pick up the phone and call your vendor to ask them why you're seeing behavior. In the past, we've never dealt with a storage vendor where they could tell us anything other than, well, you probably need more disks. Now I know what's going on, and it's really, really great. So we're using NFS v3 just because v4 is sort of rocky on Linux. You want to tune the record size for InnoDB to 16K. We are using RAID 1+0 on the appliance with striped Logzillas, those the write SSDs. The MySQL is still like CPU or concurrency bound on our clients. A single client, we haven't been able to drive an entire Toro, but that works fine for us because we're just stacking them. If you are compressing, use LZJB, not gzip, because it's much, much faster. It won't impact your write latencies. In theory, there are some other tunables in InnoDB you can use, like turning the double write buffer off or checksums off. We've tried it both ways, and at least on our workload, we didn't really see a difference. There are some problems. I talked about the replication info files not being synced. So we saw a slave that had its info files 2 months out of date from the actual replication state. So the solution there is use transactional replication so that you don't care about those info files anymore. And then there is some stuff on the net about problems with NFS locking and InnoDB. We have yet to drill down on what exactly that means. There seems to be very little data other than some people saying, I think it might be NFS locking that's causing the problems. But I will certainly blog about it if we learn anything interesting here. And we're working with MySQL on that actively. So we're looking into 10 gigabit to maybe reduce our write latencies even further. But it turns out that all the 10 gig Ethernet drivers are optimized for throughput, as you would imagine, rather than latency. So we're just barely starting this, and we need to figure out how to tune the drivers. But it's 10 gig is really, really cheap now with copper cables at $50 instead of the optical ones at more than 1,000. And companies like Arista are offering really fast switches for less than $500 a port. And we run everything else on Toro too, as you can imagine. So our revision control, email, the stateless Linux mounts I mentioned before, we toss all that stuff on these boxes and they turn out to be great too. So what does the future look like for us? Well, we can't wait to be 100% SSD someday. It's still way too much money for a large installation like us, but if you are a few gigabytes to maybe low hundreds of gigabytes, there are solutions now. We haven't played with them yet, but we want to. We think InnoDB will continue to improve. The community has really been on fire, and MySQL and Oracle have both been great about accepting patches. We're excited about multi-threaded slave replication. There's a preview that went out last week. We haven't played with it yet, but it looks promising. And we're excited about Drizzle and all the new storage engines, as I already mentioned. While I'm up here on my soapbox, I may as well talk about the Oracle acquisition and what I, as a customer, would love to see. I'm certainly hoping that Oracle is smart. Larry is a smart guy, so I have to imagine they understand this. But we're hoping that they will realize that MySQL is not some sort of a gateway drug to Oracle, that they're both great products, and that they should be treated the same way and be fed appropriately and given the right resources. Oracle is the developer of BitterFS, which is the theoretical Linux answer to ZFS. Well, now that ZFS and BitterFS are going to be under the same roof, I think the sane thing to do is to kill BitterFS and just ZPL ZFS so that we can all use it. One of the reasons Google and Percona have had to release patches and we've had to go to Percona to get some of the things fixed that we've needed to get fixed isn't because MySQL doesn't want to help us. It's been because there's been this wall between MySQL and InnoDB and the licenses and everything that has made it hard for them to innovate together. So we think them being under one roof could be a great opportunity here. Open storage, the Toro box I just talked about, is a game changer, so I'm hoping they don't kill it. And finally, I'm hoping Oracle will listen to their new communities. I'm a busy guy. I'm not up here because this is going to be a big win financially for my company. I'm up here because MySQL and these technologies are important, and participating in the community is important. So thank you very much. I do blog about this stuff all the time. You can follow me on Twitter. I will be around this conference, and I'm giving another session upstairs at Percona later today. And I will try really hard to answer your email, but my inbox is crazy. So thank you very much.